functions. What does it mean for a function to be continuous at a point? Well, I'm going to first give a definition that's kind of informal, but it's easy to understand. And then after that, I'll give a definition that's mathematically rigorous, but it'll require a little bit more explanation to understand what it means. So let me write that down. What does it mean for a function f of x to be continuous at some value a, at some value x equals a? Well, the informal definition that I'm going to give is as follows. If we look at the graph of f, and there's no breaks in the graph at x equals a, then that's what it means to be continuous, informally. So first of all, I should say first of all though, f of a has to be defined, right? And there are no breaks in the graph. I'm going to give some examples in a second, so if you're not sure what I mean when I say there's no breaks in the graph, don't worry, I'll do some examples in a second. So there's no breaks in the graph at the point a comma f of a. So what do I mean by this? Well, let's take a graph, and let's say this is the number a, okay? And here's our function. So this point right here, this y value would be f of a, right? So this point would be a comma f of a. So f of a is defined. If it wasn't defined, then what would happen? Well, there would be a little hole there, right? If f of a was not defined, it would look something like this, right? There'd be like an open hole there. But in the original graph I drew, it was solid. So that means that the function is defined there. And are there any breaks in the graph? No, there's not. It's nice. There's no jumps or anything like that. How about I do another example where